Hello and welcome. In today's talk, I want to talk about migrating MongoDB University from SQL to MongoDB. I want to start this talk by giving you some background on what MongoDB University is and why was it using SQL in the first place. And then I want to talk about why we should move to MongoDB. Despite that we work here, we still need to be able to justify making an investment in migrating from one database to another. And finally, how did we do it? What are some things that we did well? And what are some things that we didn't do well? And my hope is that those of you who are considering migrating to MongoDB or starting to use MongoDB from scratch can use this talk as a reference or something that's helpful for you. So what is MongoDB University? It's a website where anyone who wants to learn about MongoDB can go and take MongoDB classes for free online. And this is a screenshot of one of the courses that we offer. The main content in our website is that you watch lecture videos to learn about MongoDB, and we quiz you on your knowledge. We also have you do small projects to help you apply your knowledge. So why was it using SQL in the first place? Well, to learn about that, we need to look at the history of MongoDB University. So the site started in 2012 with the aim of, teaching anyone who wants to learn about MongoDB. And we knew that starting the project from scratch would take a long time and take a lot of resources. But we wanted to reach out to students as soon as possible. So what we did instead is to reach out to other companies that already had online education platforms. And we hoped to borrow their software. And the company that we found was edX, who happened to use a MySQL and Python Django stack. Now, this is a natural choice if you're using the Django web framework because it is tailored to work well with SQL databases. So knowing that it would take a long time to get Django to use MongoDB, we decided to just was there and try to launch the site as quickly as possible. So given that you have a site that works well, why should you move to MongoDB? And we can sort of try to do a pro and con table to see if it makes sense. And this is for our specific website, but it probably applies to a lot of other websites that are using SQL. So the first thing to consider is that the site was working fine just as is. And this is actually a big point of inertia because when you change something on a working site, you're very likely going to break it. And given that it takes time and resources to make this change, it would be unwise to do something like that just to break something. And as I mentioned, Django is tailored to use SQL. So it actually takes a lot of work to move to MongoDB and still use Django. And consider also the fact that one of the big advantages that MongoDB provides over SQL is horizontal scalability. But MongoDB University actually doesn't need to scale because our application is still small enough that it would run okay on a decently powerful machine. And this could actually be surprising, but there was no pressure from higher management to move off of SQL to MongoDB. In fact, it was the developers, including myself, who wanted to really try MongoDB, but it had to compete with other higher priorities that we had at the time. So building out new features, such as certification. On the flip side, moving to MongoDB does provide some benefits. As a developer, one of the things I like most about MongoDB is that it provides an interface that is more natural for programming languages than SQL. And I'll show an example of this on the next slide. MongoDB also provides a flexible schema. And finally, MongoDB allows you to integrate with some of the really helpful services that we have for developers and operations, such as Atlas and charts. Here is an example that I hope illustrates why MongoDB is easier for developers to work with than SQL. If you look at the SQL query, you can see that it's basically a string. So it's hard to tell whether you made a mistake or not until you actually run the query. You could have a spelling error or you could have words out of order. But with Pymongo, you're passing in a dictionary instead of a string. So it's already enforcing some structure. And naturally, the key is the field in the document that you're trying to search against. And the value is the value of the field that you're trying to filter. And take a look at the returned result. In SQL, the returned result is a list. And so it's hard to know which index to look at to get the information you need. So let's say that this is a database of user information. So it has a user email and their physical address and maybe some other information. But you just want a particular person's country. In SQL, you have to know that the country is the fifth element in the list. But in MongoDB, you first go into the user's address field, and then you go into the country field inside the address. So it's easier to remember, and it's more naturally structured. Here's an example that shows the flexibility of MongoDB helping our application. We offer students like quizzes in order to enforce their understanding. And we have different types of quizzes. So we have multiple choice and we have text problems as well as a couple of other ones. But we don't want to have to store each of these problem types in a separate collection. They should ideally just all be in a single collection of problems. But that would be a little bit tricky to do in SQL. Whereas in MongoDB, it's very easy to have one document structured one way and another document structured a very different way. And in this example, you can see that we have this field called type, which determines whether this is a multiple choice problem, a text problem, or some other problem. So the bottom line there is that MongoDB is easier for developers. And this is great when you're trying to develop an application. So how did we actually make the move? So one advice that our team has for anyone who wants to start using MongoDB in their application is to start with a very low risk project. So rather than trying to move an existing feature from using SQL to using MongoDB, why not start with an entirely new feature that didn't exist before? That way, you don't have to touch any existing code or change it. You can just add new code that happens to use MongoDB. Once you've got that to work and you've gotten more comfortable with MongoDB, you can try migrating one existing feature. And if you get that to work well, then you can go ahead with migrating the rest of the features in your application. And this is sort of what we did with MongoDB at MongoDB University. So when I first started at MongoDB University, none of the developers were MongoDB experts. The team was relatively new, and we had some internal training, so we knew the basics about MongoDB. But I certainly had not had any experience trying to use MongoDB in an actual application in production. So the first thing we did was we looked at the new features that we had to develop in our plan, and we decided to pick one of those and try to use MongoDB for that, sort of leaving the rest of the site alone. And that was certification. So despite all of us being new to MongoDB, we were able to successfully develop certification using MongoDB, and it worked fairly well. But we found some limitations with Pymongo, as in from a developer's perspective, we felt that we could use a framework that could help us more easily develop against MongoDB. So in 2015, we revamped the certification feature to use a library called Mongo Engine, which was also developed by an employee at Mongo. So after that, we were feeling pretty confident about MongoDB, and we wanted to use MongoDB elsewhere. So in around 2016, we decided to convert the existing Courseware feature, which was using SQL, to use MongoDB instead, using the same library. And this was a much bigger effort than certification, because not only were we developing a feature to use MongoDB, we had to migrate the storage from SQL to MongoDB, but not break the existing site in the process. So this was much bigger and it involved more people, but we did get it to work. And then in 2018, we decided that we want to use GraphQL to provide a nicer interface for our front end. So in doing that, we decided to actually try a newer library that the Python driver team had developed called Pymongo. It was meant to be sort of a successor to Mongo Engine, and also more easily integrate with Django. And so we were able to convert Courseware to use a GraphQL interface. And now we're still in the process of migrating all the other tables from SQL to MongoDB. We just finished migrating the course completion pages from SQL to MongoDB. So one thing that you notice here is the timeline that spans like 6 or 7 years, and we still haven't like completely migrated off of SQL. And the biggest reason for that is, as I said before, there was no super high pressure from anyone to get off of SQL. The site was working fine, and we only moved to MongoDB when it really made sense for us to do so. This is just a brief mention of the certification version 1 that we worked on back in 2013. So there's basically 3, I guess, groups of things to consider when you're trying to develop a certification feature. One is the exams. So the exams were interestingly stored in an XML content. It didn't use any database because an exam is just a list of problems. We also needed to store student registration, and we did this part in MongoDB. And the student registration just shows which exam the student actually registered for, and it tracks whether the student passed or failed. And although we used MongoDB for this, we didn't use any embedding. So we could have just as easily stored the registration in SQL. And we did this because we were fairly new to MongoDB, and we were sort of still in the SQL mindset. And we also wanted to do something that we were comfortable with. And MongoDB is actually nice in this way, in that it doesn't force you to use like a particular structure for your data. You could use MongoDB collections like SQL tables if you want. Or if you're feeling a bit more adventurous, you can use embedding and other MongoDB specific features. And finally, there's student progress. And student progress tracks student submissions. So how the students answer the problems. And you might think that there is some overlap between student progress and student registration because it's both records about what the student did for a particular exam. And that is true. But we stored student progress in SQL because student progress for exams was much like student progress for regular courses. And we already had code for regular courses that used SQL for student progress. So rather than try something new there, we decided to just reuse the same code and store student progress in SQL and just use MongoDB for the new feature specific to certification. So I mentioned that Courseware was a much bigger project. It also took a lot more convincing to get management on board because it was a lot of effort and maybe for no obvious benefit, at least at first, because at the end of this migration, the website would still look and function the same way. And that was how we defined success. But in doing so, it meant that we would spend all this time and effort on the back end with no noticeable benefit on the front end. So we were, as a team, hesitant to take on this project for a while. And eventually, what we did was we sort of did the project in secret. So we had this period where developers can spend 20% of their time working on whatever projects that they wanted. And I decided to spend this time converting Courseware from SQL to MongoDB. So I did this for about 3 or 4 weeks and got something that worked. And when I demoed it to other team members and management, they were surprised that I was able to get something working in a short period of time. And also, they didn't notice anything on the front end. They just thought that it was still using a SQL database. So that proof of concept was enough to convince people to start this project. And it actually ended up that one of the summer interns in our team did the bulk of the work, which goes to show how easy MongoDB is to just pick up and run with. So what are some things specific to running Courseware? So I mentioned that with exams, there's basically exams and student registration and student progress, and courses in some ways are very similar. So a course, it also has problems, but in addition to problems, it also has lecture videos and other ways to teach students a particular topic. And it's organized into chapters and lessons and so forth. The student progress is also very similar in that its core function is to store the answer submissions from students for particular problems. In addition, we also store whether a student has visited a particular lesson or a problem. And one interesting feature to consider about this is that there are many students per course compared to exams. So an average course on our site would maybe have 10,000 students like per offering. And this sort of helps to guide how the database should be modeled. I mentioned that the exams were originally stored in XML, and this was also true for courses. So one of the things that we wanted to do, and even though this is not strictly a SQL to MongoDB migration, we wanted to get off from using files to store courses to the database, because using a database to store data gives you some more flexibility in terms of being able to query for things that you want to search for, and also not having to just keep the courses in memory all the time. The old way of storing student progress was, of course, to use a SQL table. And this is the largest table in our SQL database at the time we started the migration process. And consequently, it's the largest MongoDB collection that we have after migration. So this was probably the most important part of the entire migration process. And the old way of storing the student progress was kind of interesting, because it was basically storing student ID, course ID, problem ID, as you would expect. But there was this one column called state, and it didn't store some primitive data type like a string or a number. It actually stored a JSON data in a column. So if you look at these examples, there's the answer key, the score key, and the submit date key. And this was not something that the MongoDB University team had designed. This is what the code that we borrowed was doing, because the courseware needed some way to store different types of data. So the first row stores a check all that apply answer submission, and the second row stores a text answer submission. And this kind of flexibility was tricky to do in SQL. So the original developers just decided to put JSON on the column. So this is, I guess, kind of a smell that something should be improved. And when we were looking at migrating this table into MongoDB, the simplest thing to do would have been to just directly translate all the columns into fields in the document. So this example has a student ID field, course ID field, problem ID, and the state as before. But note that this is in some ways already better than the SQL approach, because rather than storing a big JSON string in one of the fields, we can just store the JSON naturally as an embedded document. But one of the things that MongoDB engineers will preach is to, rather than just directly translate a SQL table to MongoDB, take advantage of MongoDB's flexible schema and embedded documents to try to do better than what you used to do in SQL. So after going through several iterations of what an ideal data model might be, we settled on something like you see here. So instead of having a document for every user problem combination, so just to remind you, there are two documents previously, one per every problem and student. But this model that we settled on stores every lesson that a user has taken for a particular course. So you can see that there's this embedded document called units, which stores a document for every lecture and problem that the user has visited. So one question is, why did we do that? And the answer is that we modeled the database in such a way that it would perform like the best for the most frequent use cases. And the most frequent use case is students viewing courseware. So when students are viewing courseware, they're in one course at any given time. And within that course, they're browsing content in that course. So lessons and chapters within one course. So rather than having to do a MongoDB query every time the student wants to see a particular lesson, we just store student data on all lessons in that course in one document, so that you only need to fetch the document once and you have all the data you need for the particular course that the student is taking. So this is what some might refer to as a top-down approach, where you look at how the website is using the data to try to guide how the data is modeled. And it is good to optimize for queries, because most any application will do many more queries than they do updates or inserts. And you might think that, well, we should just make the document as large as possible, so we just need to do one query for anything. But at some point, you discover, as we did, that this is a bad idea, because a document model that is optimal for one feature or use case turns out to be suboptimal for other cases. And over time, you end up becoming closer to a relational database. And finally, you need to consider the performance, which also is very much tied to how users use your data. And I want to elaborate just a little bit on the pros and cons of embedding. So having embedded documents is good, as I described, in that you don't have to do as many queries to get the data you need. But the danger is that when you have a document that has a lot of data inside one document, and you have queries that are really just interested in some small parts of this document. So you're just interested in one of the many embedded documents. Then the query can be pretty complex to write. And also it could end up having suboptimal performance. So one common use case for web applications is that you write this page and you have modeled your data to optimize for like the user experience. And then after that, the admins come in and say, well, I want to run some reports on the data. And they discovered that the data model that works so great when you're loading web pages doesn't work so well when you're trying to generate reports. I want to also talk about how developers would optimally access their database. So as you may recall from the timeline, we started with Pymongo to use all database-related functions. And this was the MongoDB's query language, and it gets closest to MongoDB in that there are no intermediate layers that might decide what queries execute and when the queries execute. So we thought this was the best way. But after we spent some time doing development, we discovered that Pymongo, for all its strengths, has some things that are missing, which we felt would benefit our development process. So we turned into using ODMs, which stands for Object Document Models. And there are some advantages to ODMs, which is that ODM allows you to write Python classes that represent documents in the database. So you're dealing with class objects rather than Pymongo dictionaries, which is nice because classes inherently provide type checking. And it also leaves a record of like what documents look like in your database in your code. So if you want to know the shape of the documents in a particular collection, you just need to look at your class definition. And it's also more convenient as well because with dictionaries, you're constantly having to type brackets in order to access contents inside the dictionary. But with class objects, you just use dots. But how about performance? Performance is something that we kind of overlooked a bit because our website is pretty small and we didn't need a huge amount of scale. So whenever we develop features, things just kind of worked fast enough for most users. But over time, as we wrote larger and more complex features that needed either complex queries or aggregation, we learned that actually we did have to worry about performance. But the one lucky thing about spending a lot of time trying to optimize your data model is that you have inherent performance gains just by having a nice data model. So As I mentioned, one advantage of having embedded documents is that you have to do less queries to get the data you need. And doing less queries often leads to better performance. And after you write your queries, you look at which queries are slow and need improvement, and you put the appropriate indexes on those queries. And this is very simple performance tuning, but more often than not, it was enough. But it does become an issue. So as I mentioned, trying to generate reports also hurt us here a little bit, because reporting usually looks at lots and lots of data at once. So for example, maybe an admin wants to know how many of the students passed at least one course in a particular year. So you would have to look at all the students that have taken courses over the span of that year and try to do queries and aggregation. Another place where we had a performance issue was when we started building single view pages. So we have a dashboard that shows a summary of all the courses that a particular user has taken and how they did on each of those courses, and whether they can take a new version of the course if they failed it, or view their course completion certificate after they passed it. So what are some things that we have remaining? Well, we want to move the rest of the SQL tables to Mongo, or this is a personal goal, so that we can finally stop telling people that we use SQL at MongoDB. We also want to try newer MongoDB features, such as schema validation and transactions. That's all. Thank you for sitting through this talk.